consider a sequence of polynomials with real coefficients defined by p naught x is equal to x square plus 1 into x square plus 2 and so on, x square plus 1009. So we are having 1009 brackets and every bracket is a quadratic. So we can say that p naught x is 1009 into 2, that is 2018 degree polynomial. Okay, now they are defining subsequent polynomials pk plus 1x is equal to pk x plus 1 minus pkx. That means my p1 next polynomial will be p naught x plus 1 minus p naught x. Now dear all, please understand, if p naught x is polynomial of 2018 degree, so would be p naught x plus 1 also 2018 degree, because we will be replacing x by x plus 1. This will not change in the power of x, maximum power of x. Okay, but if you take the difference of these two, in p naught x plus 1, if I put x plus 1 in place of x, leading power, leading coefficient will still remain 1 only, and that was 1 in p naught x also. So if you take the difference, leading term will get cancelled. So this p1x will be a polynomial of 1 degree lesser. And also you can prove it that if it is 2018 degree, this p naught x plus 1 will be having some terms which are of degree 2017, and p naught x is not having any term of x power 2017. So this difference will be 2017 degree polynomial. I'll repeat what I said. What I said, that p naught x plus 1, if you write, this will be in the bracket x plus 1 whole square plus 1 and x plus 1 whole square plus 2 and so on and so on. Okay. Now if you multiply all powers of x together, you can see there will be a term which will be x power 2018. It is when all highest powers of each brackets are multiplied. But you will get some term which will be having power of 2017 also. You just have to do, multiply one of x of one of the bracket with all x square powers of all the brackets. This will give you 2017. And because there is no negative sign, you can expect that this will never cancel in this calculation. In p naught x, we are not having any odd power. So in taking difference, this p1x will be of degree 2017. Okay. Now similar to this, p2x, if we solve for p2x, which will be difference of p1x plus 1 minus p1x, we can directly conclude that it will be 2016 degree polynomial. So every time we are increasing this 1 to 2, 2 to 3, this degree is getting reduced. So if we keep on doing this way, I think p 2017 x will be a linear term, linear polynomial. What I am using the logic that this sum 2 and this 2016 is 2018. Here also 1 and this 2017 is 2018. Here 0 and 2018, sum is 2018. So every time we are increasing number here, degree is getting decreased by 1. So my 2017 will be linear polynomial, and p 2018 x will be a constant polynomial. And after that, everything will be zero polynomial. P 2019 x will be zero polynomial. Now the next part of this question says find least value of n such that pn1, pn2 and so on, pn 5000, they all are equal. Now dear all, if pn is some polynomial having roots as 1, 2, 3 and so on till 5000, it has to have either at least a degree as 5000 or it has to be a constant polynomial. Then only we can say these two be equal. Suppose this is equal to k. Okay, then suppose p and x is some polynomial, so then Pnx minus k will also be polynomial, and this is equal to 0 will give you 5000 roots, 1, 2 and so on 5000. But what you can notice here is that even this P naught x is 2018 degree polynomial. So how is it possible for some n positive integer? I think they are talking about positive integer only. It has to be, because they have not talked about for lesser value than 0. So I will assume this has to be positive integer. So in this case, it is not possible this to be 5000 or bigger degree polynomial. So only possibility is that we should have n such that this becomes constant polynomial. And that will be possible when n is greater than or equal to 2018. Because 2018 onwards, all these polynomials are constant polynomials. In fact, after this 2019 onwards, it is zero polynomial. This will also satisfy this, but 2018 is the first number, so we can say that least value of n. So the n least here is actually equal to 2018. So this is the answer of this question. Okay, so this question, again I'll say, if you are good at polynomials, I think this question is not difficult at all. In fact, I like to connect this question with one thing which we teach you in sequence and series. If you remember, we used to tell you that if you have a, let me take another slide. We used to tell you that if difference of two terms are constant, that nth term is linear in n, and that is called as AP. If difference of difference is constant, then it's a quadratic. If difference of difference of difference is constant, then it's a cubic. Okay. Now here, if you notice what we are doing, or let me do one thing, let me tell you one more thing here, that here Tn plus 1 minus Tn will be constant. Here Tn plus 1 minus Tn will be linear, maybe some other constant Pn plus Q, and here Tn plus 1 minus Tn here, that will be quadratic. Okay, so in this question also, what you can think of that replacing x by n, this will give you nth term of some series, some progression whose difference of some terms will be constant. Okay, now this can be taken as n plus 1th term if I replace x by n, and this as nth term. So difference of two terms here, and we are calling that as the next polynomial. So what I'm trying to tell you, so as every time if your nth term is cubic, the difference of two consecutive terms becomes quadratic. If it is quadratic, difference becomes linear. So every time 1 degree is getting lowered. So if that is so, I think we should be getting and then we should be getting here also the same thing, that every time this p k plus 1 will be of degree 1 lesser than p of k, and this, using this fact,